Welcome to Chapter 3, everybody. Chapter 3. In this chapter, we're going to take a little bit of a mathematical detour. We're going to pause the physics for just a couple of days, and we're going to look at vectors. We're going to say more about them. Now, we've already said a little bit about them, and to remind you of what a vector is, it is a quantity that is really a collection of two quantities. It's really, a vector has two parts to it. A single vector has two parts to it. It has a magnitude, right? And it has a direction. Two parts. Okay. And as an example, we have three vectors I've drawn here. Now, a couple things to say. One is that notice these lines you see over each of these symbols. This is a velocity, this is a displacement, this is a weight. These are each vectors, and to symbolize a vector, your textbook puts the symbol in bold and puts a little arrow over it. So, for example, V would look something like this. It'd be a bold V with a little arrow over it like that. In order to save time and my own sanity, I don't do the bold, I just draw the line. So when you see a quantity that I draw with just a line over it like that, that's a vector. So these quantities are vectors, these are not. No lines over these. That's mass, temperature, and height. There are no lines over those quantities. So I indicate a vector by just putting a line over the symbol. We haven't done this so far, but we're doing it now from here on out. Okay, so those are all three vector quantities, and each of them have a magnitude. In the case of this velocity, 3 meters per second. Okay, the magnitude of the displacement r is 4.2 kilometers. The magnitude of the weight is 120 pounds. But each one of these quantities not only has a magnitude but a direction. The direction is in green here. For example, the velocity is 3.0 meters per second in the positive x direction. The displacement is 4.2 kilometers to the northwest. Right? A displacement is when you go from one point to another. The magnitude is how far you went, and the direction, in this case northwest, tells you in what direction you went. And the weight of an object points down, right? We haven't talked about weight. Weight is a force. Haven't talked about forces yet, but weight is a force, and you can appreciate that weight takes a body down, as demonstrated there by my very dramatic pin-following demonstration. So vectors have magnitudes in pink and directions in green. Scalars are just numbers. They could be positive or negative numbers, but they're just numbers with the appropriate unit. Notice that the magnitudes have units. Okay? And scalars also carry units. Okay? Now, not every scalar has a unit, right? How many apples are there? There are 4. There's no units, just the number 4. That's still a scalar. But most scalars that we deal with and most vectors have a unit associated with them. So, two parts to a vector, magnitude and direction. And the other new piece of information for you is that we notate them with a line. I notate them with a line. Your textbook notates them by making the boldface with an arrow above. Okay, so those are examples of vectors. Now let's look more closely at vectors. When we dealt with only one dimension, we didn't have to worry too much about how we dealt with vectors. Okay, but when we deal in 2 dimensions or more, we have to think about it. So let's just imagine something here. Let's imagine that you were standing in front of the old courthouse in downtown Decatur, right there on Ponce, looking right down Claremont toward the traffic light. Okay, you're in front of the courthouse. So here we go. Let me draw a map for you. Here's the courthouse. Okay, you're standing right out in the street in front of it. Not safe. Don't go standing around in streets. Okay, but you're doing it anyway. You're being unsafe. Okay, you're standing in the street. And let me draw a couple other streets here. Okay. And down here, well, you're standing there in front of the courthouse in downtown Decatur, and somebody comes up to you and says, how do I get to the Victory sandwich shop, the sandwich shop / bar thing? How do I get to Victory? Or, where is Victory? And Victory is down here on Church Street. Okay, so this is Ponce, East Ponce really, and this is Church. Okay, so this is a person new to town and wants to know where Victory is. Well, you can say Victory is 360 meters to the southeast, which is correct, right? Between the court where you are, okay, and Victory, and I'll just put a point out here in front of Victory to make my drawing work better. This is not the actual number, but let's just say that for the sake of discussion, that distance is 300. Actually, I think it's actually 361. That's not the actual number. That's just the numbers I've worked out in my notes. So 361 meters. So stranger comes up to you and says, where's Victory? And you say 361 meters to the southeast. That's a vector. That's a displacement vector. And we give the displacement vector symbol R. We've not seen that before, but that's fairly standard way to write a displacement vector. Okay, R with a bar over it, because it's a vector. So it's to the southeast, 361 meters. Okay. So that's actually correct. That is actually the answer. Where is Victory? You point to the southeast and you say 361 meters that way. But when your friend or when the stranger actually walks there, they're not going to walk on a straight line between where you're standing in front of the courthouse and this point here right in front of Victory. They're going to have to walk they'd have to cross over like all kinds of buildings and parking lots and go through walls and stuff if they took that straight line. They're not a bird. All right, what the stranger's going to do and what you're going to tell them is you're going to say walk to the east 200 meters okay, until you get to Church Street, turn right, and then go south 300 meters. See if I can write sideways. That's fun. Okay. And you will end up at Victory when you do that. That's what you're actually going to say. If they ask you the question, where is Victory, you can say that direction, 361 meters. Or if they were to ask, how do I get to Victory, you would say, go east 200 meters, turn right at Church Street, and go south 300 meters, and there you'll be at Victory. Right? Now notice that whether you're a bird flying from the courthouse to Victory, or whether you're a pedestrian walking from the courthouse to Victory, you end up at the same place. Your displacement is the same. Okay, the displacement is the same. So if we were to sort of impose on our little world here an XY axis. Okay, what you would say is you would say 200 meters in the positive X direction, and then 300 meters in the negative Y direction. Right? Because positive Y is up, negative Y is down. We can either talk about east, west, north, and south, or we can talk about plus or minus x and y. So if you put this into xy language, you could say this. You go 200 meters in the x direction and 300 meters in the negative y direction. Okay, so our vector, this is our total displacement vector. Whether you're a bird and you fly straight to victory over the buildings, over the parking lots, or whether you're a pedestrian and you walk 200 meters in the positive x direction and then 300 meters in the negative y direction, you're going to end up at the same place. So your displacement is the same. Okay. These two numbers, in this example, 200 meters and 300 meters, are called the components of the vector r, of the displacement vector. So r is the displacement vector. Okay. Again, whether you're a bird or whether you're a person, you start here, you end there, and all displacement cares about is where you started and where you ended, not how you got there. It doesn't matter if you start here and you go to, Egypt and come back from Egypt and then walk down here. From the time you started to the time you ended, if you started here and ended there, no matter what trip you took between the 2 points, r is your displacement vector. Okay. R sub x is known as the x component of r, and in this case that equals 200 meters. There's an implied positive there. So Rx is known as the x component of the displacement vector r. Right? Because we set up our axis this way. Because we set up our axis the way we did, motion in that direction is in the positive x direction, motion that way is in the negative x direction, motion that way is in the positive y, motion that way is in the negative y. So in this case, R sub x is the x component because it's moving along the x-axis. And it happens to be positive because you're going in the direction we define to be positive. Okay. R sub y is the y component of the displacement vector r. And that y component in this example here is minus 300 meters. Because in order to go from in front of the courthouse to in front of Victory, you had to go 200 meters in the x direction, positive x direction, and 300 meters in the negative y direction. Therefore, these values here are the components of r. And if we had a different vector, say we had a vector named a, then that vector has components ax and ay. We're not going to worry about the third dimension right now. There is a z as well, but we're going to skip that. So any vector has components x and y. So if we call the vector, alpha, we'd have alpha sub x and alpha sub y are the x and y components of alpha. So that's what components of a vector are. How far the vector goes in the x direction, and then how far the vector goes in the y direction. And the subscripts show up. When they see the subscripts on a symbol like that, that means that is the component of that vector in those directions, x and y. So the big idea, or the big ideas in this particular little video, vectors and scalars are different. That's review. We indicate scalars, we indicate vectors by putting bars over them. Textbook uses arrows. And then we have these ideas of the components, which is really the main thing, the new idea here, the components, the x parts and the y parts. And we'll be seeing this show up again and again and again, especially over the next few videos, but then throughout the semester. All right, next up, what do we got? Oh yes, a little bit of trigonometry review. All right, so we have that to look forward to, and then we're going to put the trigonometry together with the vectors. All right, so that's it. Components, don't forget. That's how they work.